Number 6. Which axis shows the symmetry of the graph of the function? Let's see. Which axis shows the symmetry of the function? And I have f of x equals x minus 2 squared plus 1. So what I want to do here is I'm looking at which axis shows the symmetry. So I'm looking at what is either the x or the y-axis that shows the symmetry of the function f of x equals x minus 2 plus 1 here. So what we want to do with this function here is we know actually the vertex of this function, because this function is currently in vertex form. It's something you learn kind of in Algebra 1 or in grade 10. So we know that this function is in vertex form. And how do we know that? Well, it's given by these two coordinates here. So I know that the vertex of this formula of this equation here is 2 and 1 here. So if I were to kind of graph this, and you can solve this actually graphically or algebraically, it's kind of up to you how you solve this problem here. But if I were to draw a graph of this function, I know the vertex is 2 and 1 here. So I can kind of estimate here, this is 1, so here's 2, 1. So this is kind of the vertex of the formula here. And it can either open upward or open downward. And in this case, because my a value, and this here is the imaginary a value, right? This guy here is the imaginary a value. It's equal to 1 in this case. It's actually positive. So I know that my parabola is going to open upward. So you can say that the parabola looks something like this. It looks something like this, and it won't open downwards because it's not reflected in the axis here. So again, it's asking us which axis shows us a symmetry. So let's look at the solution and let's see what they're doing here. So it says we have the following function. Okay, that's good. So they graphed it, which is good, and they actually solved for the y-intercept here. So actually, it's a probably good thing to solve for the y-intercept as well. So let me just solve that for you real quick. Because this graph is technically inaccurate without the y-intercept. So let me just, because we only know the vertex here. So let me solve for the y-intercept for you as well. So honestly, all you have to do is just set our x value to 0, right? So to solve for our y-intercept, we're going to solve x here equals 0, right? So we can say that f at 0 is going to equal 0 minus 2 squared plus 1, 0 minus 2 squared plus 1. This is 4 plus 1, which is equal to 5. And as you can see, this here is at 5, right? So we can say that this here, maybe like somewhere up here is 5. So we can say it's something, it looks like that. Looks like the parabola here. Obviously, I didn't draw it very nicely, but this looks something like the parabola here. And as you can see, it's the parabola is something like that. And then what they're doing here is now they're saying the vertex is a 2 and 1, which is good. So we know it's in vertex form. And we know the line of symmetry is x equals 2, which is parallel to the y-axis, right? So again, the question was asking which axis shows the axis of symmetry. So actually, let me draw this a bit better here. And it's actually very hard to draw because my graph isn't my graph isn't to scale here. That might be the best thing to do here. But what I'm doing is which one shows the symmetry here. And what you can do is you can actually draw a dashed line here right at the vertex for you to figure out that these two places are supposed to be symmetrical. It doesn't really show it in my diagram, but both of these sides here are symmetrical. So meaning that so this means so I'm going to write a therefore statement. And therefore, at x equals 2, you can say it shows the symmetry of the function. It shows symmetry of the given function. And this here is our answer. X equals 2 is our answer. And this is correct as well. And the reason why we know this is because we can draw a dashed line at x equals 2, and we know that this side is symmetrical to this side. So when we say symmetrical, we can say that if it's reflected along x equals 2 here, it's going to be the exact same curve or the exact same function between both of these sides. So if we reflect this side onto the left side onto the right side and the right side onto the left side, it is the same function here. So this solution here is correct. And we actually didn't really need to solve for the y-intercept. They just did it just to show proof of point in terms of graphing. But we really just care about, in the vertex form, really we care about the vertex, right? So this is 2 to 1. And we know the axis of symmetry it basically goes, in this case, it would go right at the x coordinate here to divide the kind of parabola in half to make it symmetrical. So the solution here is correct.